Hello, this is Team Outliers, and then today we're going to show you all the results from Lab3 Part 2. And along the way, we'll also show the functions that we built for Lab3 Part 1. And Raj will first show you guys how our interface work and then how all the functions work.
Hello. I'm going to discuss about some of the functions we have created for Lab3 Part 1, and I'm also going to show our database schema. So let's run Lab3. For this Lab3, we have created a graphical user interface for stock application instead of like the terminal one. Like the terminal one. Let's run this code and you will see a stock portfolio application. So we have built up this application with all the robustness and yeah, if it also displays the each and every message, like the alert box. If I, example, if I type a wrong password, it will show like the invalid credentials. And if I type a right password, yeah, it will say login successful. And this application has a number of functions. Say example, this is one of the tasks in Lab3 Part 1 to display the real-time stock. So by clicking this button, we will start the Y Finance API to fetch the stocks that particularly the tickers what we choose. We have choose the 7 tickers from the tech finance market. And if you start this function, it will fetch the specific tech finance market tickers for the today. It's based on real time. So as you see, if I click this function, it will say like the stock data stored successfully. And if I open this, and it will show all the stocks for today's market. Basically, it will shows the today's price. And clicking black, we come to main screen. And if you want to create portfolio, just we have to enter the name for this portfolio when we have created for all the stocks previously. And if you want to view portfolio, say example, I want to view the Apple portfolio, and I can see this Apple portfolio. And if I want to view, say example, AMD, and I can also view the AMD portfolio. And this for example portfolio, this add stock option is allow you to add a stock to the portfolio. So example, if I want to add uh, Google, the Google portfolio, I can just say mention the stock portfolio name and the ticker name and the dates to be added. The same way, like the remove stock portfolio also works. Instead of add stocks, it will remove the existing stock. So for giving this stage, the stock should already present in your database. And I can quickly share the database schema. So this is our database schema. It has all the tables, and all tables are connected to the keys or primary and foreign keys. And that's it for uh, lab 3 part 1. And also we clean the data set, and we have stored the data set in this file. This file has the cleaned and pre-processed data set for a training purpose. And that's it for lab 3 part 1. Now Claire will share his views. Before Claire, I think Tiffany will explain the moving average, and Tiffany will start.
Okay, yeah. So, to briefly describe our simple algorithm, which we chose the simple moving average. So our program first calculates the simple moving average of a company's stock with a window of 30 days, then marks the action for each date as buy, sell, or no action. And it determines the signal by comparing the close price of the stock to the simple moving average for that same date, and signals buy when the closing price begins to grow higher than the simple moving average, which indicates that the stock is performing better than usual. And it signals sell when the closing price drops below the simple moving average, which signals that the stock is underperforming. And otherwise, it just signals no action. And then our program also prints out a plot with the simple moving average versus the stock closing price. And now I will share my screen. Can you guys see my screen?
Yeah.
Okay. So to demonstrate the simple moving average, for example, for NVIDIA, this graph shows the closing price and the 30-day simple moving average, and the first plot shows the full period of more than 10 years, and then the second plot shows just the last 2 years of data. So it's easier to compare the simple moving average and the close price. And then the program also prints out when it's the best day to buy and when it's the best day to sell. Moving on, Claire, do you want to share the LSTM part?
Of course. So right now I'm going to take you guys over to the LSTM part, which is our advanced time series analysis model that we pick in the end for this lab report. And let me just share my screen. So for this part of our project, we choose short-term memory networks because it uses recurrent neural network, and then it models sequential data and then is able to capture long-term dependencies. So we first try to split the data into 70% training and then 30% testing. And then given our data ranges, all the prices after 2021 will be used as testing data. We then also normalize the data in order to using the min-max scaler so that everything is normalized. So now here's some graphs that we plot that shows the, I guess, the section between training data set and then testing data set. And these are some several stocks that we have in our portfolio. And then next, we split the data into X-train, Y-train, T-test, and Y-test, and then we fit it to the model. And for our LSTM model, we decided to implement bidirectional LSTM so it can capture both the forward and backward trends. And then we also implemented ReLU activation to help the function learn complex relationships of the data. And we further use dropouts for each layer to ensure that we're not overfitting the data. And here's the result from our model. This is the layer, all the layers that we use, and then the shape, and then the final parameters that we have. And then now we try to predict the model using our pre-trained model. And then the orange line signals the prediction from LSTM, and then the blue line is the actual price stock. So it's doing pretty well for all of these stocks here. As you can see, it like all the magnitudes and movement of stocks are pretty much captured by our model. And then next I want to show you guys the buy sell signal model that we built for LSTM. So here we decided to use the moving average convergence divergence indicator, which is MACD, to calculate buy sell signal. And we have some helper function here to get the model and then import all the data that we have, as well as predicting the price and then plotting the MACD signals. So here's the main function for our buy sell signal. So in this function, MACD, if MACD is above the signal line, then we buy stock. And if MACD is below the signal line, we sell the stock. And we also implemented stop loss and trailing stop loss to protect the investments. So after we run this function, so for example, if we use Apple as an example, this will be the final output of buy-sell signal over the course of 10 years for the stock price. But if we want to choose a specific day, we can also do that. So we can perhaps see the buy-sell signal in the range in the recent 1 month range or a 2 month range. And that's it from the LSTM part.
So we are coming into the last part of our lab assignment 3, and in that part we have to track the portfolio for across the time period for the selected ticker, and we have to we have to predict which is the perfect time to buy and sell the stock, and what is the maximum profit can yield by the user. So for that, let's log into the application again. And for this, we're gonna use this button, like investment button. And for this, we have to enter the ticker name. Please make sure like the ticker name is correct. Say example, if I entered AMD and if I entered amount 300, and for that we can actually enter the random date. Let's go 2 years back and enter a random date, and let's go 1 year behind and enter somewhat like around May, or you can enter around June also. Perfect. And when you start proceed, it will backend, it will run the model and it will load the weights actually, and then it will display the information like the for ticker AMD for the given dates. The buy price is like 67 and the sell price is 127. So total number of shares is also given additional information like total how many shares you should buy. It's generally like the 4% of the shares, and the total profit except a thing. So it's displaying like the one share price is $67 and you're selling it for $127. So total profit without the 300 it's 268, and we can also see the graph uh, sh- plotting across the portfolio. This is our total portfolio uh, close prices, and this is the actual close price, and this is the predicted buy and sell point. So from this application, if you want to invest, you can, but don't take serious action about it. It's just a fun application, and we are like not even sure like how it could be because it's trained on a historic data, and we use intermediate algorithm to train these models. So that's it for Lab 3. Thank you for hearing this.